The results of the NCAT MNRoad Pavement Preservation Study, which Adriana is going to give us an update.
All right, good morning. I think most of you are probably familiar with our preservation study, but if you're not, don't worry, I'll give you some background information. I'm sure you've heard this a million times probably. I think we can all agree at this point that preservation is a no-brainer. I mean, its benefits, you've seen it throughout the conference. However, if we want to integrate this into a pavement management system, then we have some questions. One big one is for a given type of treatment, well, what's the benefit? How do we quantify that? And as we learned in Monday's Dr. Hall's presentation, the answer is always, it depends. So that's some of what we're trying to take here. Look at the different variables and how the treatments are going to behave under different conditions. If you look up information for, I don't know, thin overlay or micro or anything like that, and try to see what the performance is going to be like, you're going to find a wide range of answers going from something like 4 to 15 years. That's not really useful. So we're trying to take all those variables and kind of narrow it down and have better information. One of the most important variables is the condition of the pavement at the time of the treatment. So that's really something that we look at carefully. So our goal for the preservation study is to develop life-extending benefit curves for each of the treatments, looking at different levels of traffic and different levels of, or different climates. At the end, just basically have those curves. And that sounds pretty straightforward, but we have to go back and say, well, how are we defining benefit? How are we defining life and life extension? So that's part of what we're trying to do. Our study started back in 2012 when we built our first sections. It's part of the 2012 research cycle. Since then, we've been adding more and more. So we started with a very low volume road, county road. Started the experiment there, then we expanded onto higher traffic volume. Then we said, well, let's build the same thing in a northern climate. So we partnered with Minnesota and just kind of grew and grew from there. So we've been doing that, and right now we're entering what we're calling phase 2 of the study, which is basically just a continuation of data collection and monitoring and just trying to get more to the analysis part of the study. Right there, what you see is a shot of the Transportation Pool Fund program and how many partners we've been getting on board. So again, we're partnering with MNRoad to just kind of continue the study. And you can get more details. There's the web link right there. But basically, we started very humbly. Back in 2012, 7 state DOTs, most of them or all of them from the southeastern region, and our industry partners as well. And then when we partnered with MNRoad, well, the group started to grow. Now the northern states are interested because we have sections in the north that are more representative of what they have. So that helped get more people on board. And now, well, we've been getting the message out for so long, and people have such great expectations that now for phase 2, we have even more people joining the study. So that's very good news. And if you don't see your own state in there, there's still time to join if you want to do that. So a little commercial in there. 2 sites. So we have our south, what we call the south part of the experiment. It's in Auburn. We have, again, 2 sites. We have the low volume and the high volume roads. So that will be representative of the hot weather, no freeze environment, very humid. And then when we build the same, basically mirror the experiment and put it in Minnesota, that's almost the complete opposite. So now we have very cold temperatures, freeze conditions, and it's still pretty wet. So for this presentation, I'm going to focus on the southern part, since this is the southeastern region after all. Again, a little background. So the 2 sites that we have, one is Lee Road 159. That's the very first place where we put any treatments down. It's a low volume road, and something that's particular to this road, it's a dead-end access to a quarry and an asphalt plant. So it's low volume, but it's a lot of trucks, something like 60% trucks. Everything that comes in has to come out with the very special case that they come in empty and then they leave loaded. So right now, after almost 7 years, inbound lane that goes to the quarry and the asphalt plant has accumulated something like 78,000 easels, equivalent single axle loads. And the outbound is more like in the 1 million range. So we're talking orders of magnitude right there. So it's almost like a 2-in-1 experiment just for that site. The high volume is Highway US 280. It's very close to the test track if you've been there also. And again, we built this one cycle after we built the Lee Road sections. So basically took more or less what we had in Lee Road, created a bit more combinations of treatments, added the coal recycling. So we have a little more treatments in there, but it's basically more or less the same. Newer sections, they've been down for half the time than the Lee Road sections, but at least twice as much traffic. So we're talking more than 2 million easels accumulated in almost 4 years, 3.5, something like that. As far as treatments, well, we obviously left some sections untreated, left there just to see what happens if we don't have that proactive approach and to demonstrate, because we know what's going to happen, so demonstrate and quantify that benefit. And then we have a good variety of surface treatments, and we have things as simple and cost efficient as crack sealing, and then all kinds of surface treatments, fog seals, chip seals, scrub seals, microsurfacing, combinations for cape seals. So we have micros on top of scrub seals, chip seals, fiber mat. We have the coal recycling sections on US 280. So we use cold in place and cold central plant, each of those with either emulsion or foam technology. So now we have more combinations in there. And then those were followed by a 1-inch thin overlay. And then we also just have the thin overlays by themselves with different types of mixes. So we have dense graded mixes, most of them, some OGFCs, ultra-thin bonded wearing cores, and we also combine those. So we put some of those on top of chip seals, scrub seals, and so on. So we have a pretty good range of options that we can choose from. For performance, and we had this question on Monday as well, what is performance? How do we define that? And there were a lot of different answers. So we're trying to capture all of those, and we look at a good variety also of indicators. We look at roughness, rutting, macro texture, cracking, of course. If we talk about structural integrity of the pavements, we're doing deflection testing, friction for safety, permeability, moisture. We have also a lot of things that we look at. So we do check regularly, depending on where we are. Lee Road is easier to just go there monthly and do some measurements. For US 280, we have to close the lanes, and it's a little more complicated, so most of the monitoring is quarterly. Performance, how do we define it? And this has been also one of the challenging parts of this, because if we start to take all our data and let's say I'll convert it into Alabama's PCR pavement condition rating, does that mean anything to Kentucky or Tennessee? Probably not, right? So the idea was, well, what do agencies have that could be common to all of them? So even though we collect all of this data, if we look at the MAP 21 criteria, everyone knows what we're talking about. So that's been kind of what we were using. So we're all speaking the same language. We still look at everything. But these 3 indicators are kind of the key also to look at performance. So we're looking at cracking, rutting, and IRI for each of the sections. As far as what we have seen so far, I'll just go through a very brief update on how the sections are performing. So starting with our low traffic sections in Lee Road 159, those were treated again 2012, so almost 7 years, 6.5 right now, that they have been down. Nothing else has been done to the section, so whatever treatment they received in 2012, that's what they have right now. Control sections, as expected, pretty deteriorated at this point. A lot of cracking, especially in that outbound lane with the heavy trucks coming out of the quarry and the asphalt plant. For each of the treatment groups, I'm going to show you those tables there that just don't have any numbers, but at least they have the category of where they are in terms of the MAP 21 criteria for each of the indicators. So we had 2 control sections on Lee Road with varying levels of initial cracking. And they're both at this point now in the poor range. That means more than 20% cracking of the total area. Rutting, not really a concern. There's the one that's getting a little higher there, but just over that threshold that goes to the fair conditions. So I think it's around maybe like 6 millimeters of rutting. And they're both good with IRI. IRI is not really changing much. As you can see there, that's an example. Pretty much constant over time. And for rutting, again, very little variations. It wasn't a concern to begin with, so it's not something that we're too concerned with. Our chip seals, we have a good variety within just that chip seal category. So we have single, double, triple layers. We have scrub seal. We have the fiber mat. If you don't know what that is, it's just basically fiberglass strands sandwiched between two shots of emulsion, and then we put the chips on top of that. So it gives it an extra protection for crack mitigation. And for all of them, as you can see, they're now in the good to fair condition category versus poor if we don't do anything. Rutting and IRI, again, not really a concern. And we see, I guess it's not surprising, if we have triple chip seals or more layers, they're not reflecting as much cracking. And the scrub seals performing very well. I noticed yesterday that scrub seals were kind of popular among all the groups when they were having the discussions yesterday. We also see added benefit of combining maybe do crack sealing and then the chip seal. So in this picture, you can see some of the cracking with just a single layer, and then the one that had crack sealing beforehand and then was chip sealed. You don't see that much cracking reflecting through. We also have to take into account what they looked like before treatment. So the one that didn't get the crack seal had only 1% cracking, but it's already developing. It reflected that and developed even more. And the other one that was 17% cracking to begin with, a little on the high side, performing much, much better. So something that seems to be very small can be very cost effective as we integrate. Another thing that we've done is within each of the test sections, we've divided it even more and taken each area. So within one section, if we had a very bad area, we look at that and isolate it. And if we had a good area, isolate that as well. And now we have different curves depending on whether the treatment was placed on something that looked good, fair, or poor. So those are the solid lines. The dotted lines or the dashed lines are a projection if we hadn't done anything to that section, taking into account the condition at the time. So it's not surprising that there is a difference between those solid and dashed lines. And if we do take our preservation approach, we're going to get better performance than if we don't do anything. And also, if we do preservation, it also matters that we choose the right candidate, because if you see there, like the red solid line, is if we took a pavement that was already kind of in the poor side, well, obviously it's going to go back to that condition sooner than if we act early on. So this is for just the single chip seal. And then single chip seal plus crack seal, you can see the difference in performance, even much, much better. Those curves barely starting to get some slope right there, versus the other ones where we can really see a lot more deterioration. One thing with the chip seals also has been texture, and it's a good example, that location on Lee Road with the load and the differences between the lanes. So on the right side is when they leave loaded, and you can see it's kind of polished and doesn't look as textured as the other lane. So we do see a difference in performance if we want to take texture as one of the performance measures. You can see they all started at around 1.6 right after treatment, and they started to decline. What's interesting, I think, is that they just kind of plateaued after maybe 3 years. So they started to lose texture, and then they're staying flat, basically returning to their pre-treatment condition, and that varied also depending on where you were. We can take initial as that threshold, or maybe we can just say, well, how long does it take it to return to an MTD of whatever we want to look at. As far as microsurfacing, most of them in really good condition. We have, again, single micros in combination with crack sealing. We have double fiber mat cape seal, scrub cape seal. So those combinations are really performing very well. Don't be fooled by the red in there for the single micros. It looks a little alarming, but they're not as poor as the ones where it didn't do anything. So still about just barely over the 20% threshold. The control sections are more like the 40-50% cracking right now. And we saw the same thing with the crack sealing. So we could place just a single micro, and that helps definitely compared to doing nothing. But we could also, be even more ambitious and put some crack sealing in there, and it's going to perform even better. And again, even with more cracking to begin with, it's at this point they're performing much better. And you can see it also in the curves here. These curves are just a summary. I'm just presenting like year by year data, but within each of those we have thousands of data points that we have to at some point take and use to just fit a nice curve and get a nice equation. So we see the difference between crack sealing or not, and how that can be beneficial, added benefit from that. Our thin overlays also performing in the good to fair condition category. It's a little surprising that we have higher IRI numbers for that, but we have to take into account these are very short sections. They're only 100 foot long. And then there's a transition between the surface treatments and the thin overlays. We didn't do any milling or anything, just kind of created that transition that causes the van to bounce a little bit and doesn't really recover that well. So we end up with higher IRI. We're not only looking at the number, we're looking at the trend to see if that changes over time, and that hasn't really been the case. So we're not too concerned with ride. The two sections that have more cracking are the ones that we had recycling. We're trying to be extra sustainable and incorporating, like it's been the point for this morning, RAP, RAS, but maybe a little too ambitious with 50% RAP and 5% RAS, which are already a high number. So as expected, we had more cracking, a stiffer mix, more brittle, cracks reflected more, still in the fair range, so not too bad. But that design was later optimized for the US 280 sections, and we didn't go as high, but still incorporated recycled materials. As far as performance over time, you can see there they were pretty similar between the two of them until around years 3, 4, and then you can see a lot more cracking in the RAS section, especially if you were in poor condition to begin with. But if you're in poor condition to begin with, this is not really the right treatment. So I think it makes a good point. This is more typical of our thin overlays on US 280. This is just one of the virgin mixes, PG 67 minus 22. All of these overlays are 3/4 of an inch, 4.75 millimeters. So very typical. You can see there are barely any cracks, even after all these years. IRI, pretty constant over time, maybe a little bit of an upward trend. We also have a section with coal recycling and a foam asphalt base 6-inch inlay. And that one, well, as expected, it took out a lot of the cracking and problems that we had. So right now it's performing very well. Again, barely any cracking that we can see, but maybe a higher IRI. So that's something to keep in mind. For the high traffic sections, these are newer sections. So those were treated in 2015. So right now, going on 4 years old. Same thing. So we have control sections where we didn't do anything, and now not only the low cracking and high cracking control, we also had like a low rutting, high rutting, low IRI, high IRI, and even a low and high texture control sections that we can use for comparison. Even though their label is low and high, between the two of them, it's very relative. They're not like substantially different, but at least we have that built in there. So for chip seals, we don't have a lot of cracking. Most of the treated sections are still in the good condition, but that may change. We're having our next closure in April, so hopefully we can start to see a little more variation in there, but I'm not really a concern with cracking. Some of these cracks are very fine, very low severity, so sometimes even the system won't really pick them up that well. Rutting, we do see a little bit more change in the high traffic areas, which I guess would be expected. And same thing with IRI. But it's also very important to look at how they were at the time of the treatment. So if we had a section that had a high IRI and we applied a chip seal, we are not really expecting that big of a change, and it's still going to be high after treatment. And same thing with rutting. We see the same thing when we combine crack sealing with other treatments. So for example, the single layer chip seal, you can see a crack right there in the top. If we crack seal, it's kind of a flushing of the sealant material, but not really the crack. It's not really there. So that has helped. But we do have a problem with multiple layers of chip seals and bleeding. So it's pretty evident. If you drive there, you'll see it. So we're looking texture. Well, yeah, we did have a pretty significant drop within even less than 1 year, but then it's been stable. We look at our friction numbers, and we don't really see a concern. So we keep having that monitored, but it doesn't seem to be a concern. It's more like an aesthetic type of thing. Our microsurfacing, same thing. Now we have a little more combinations in here. We added a micro with fibers, one with a HYMA, 2 types of double layer microsurfacing with sandstone or limestone, but basically more or less the same things that we had on Lee Road. And again, they're performing in the good to fair categories. Again, rutting seems to be more now the concern here, even though it's not really very high numbers. We're talking maybe 7 millimeters, or just over that MAP 21 threshold. Nothing too bad. And same thing with the IRI. This is the single layer microsurface, which is probably the one that's more beat up at this point. But even though it looks like it has more cracks, they're not that terrible. I mean, they have low severity. They're still pretty tight. And like I said, sometimes the system may or may not see them. So that's something that we try to validate with our quarterly closures and kind of also walk the sections, look through them, and see how they're performing. Other types of micros are doing very well. So the double layers are especially performing in a good state. And then that's probably more representative of what you will put down in a higher traffic area. So you probably wouldn't just place a single layer microsurface, you'll go with a double. There's the HYMA microsurface as well, so very few cracking in those. And those are some of the top performing micros that we have. And the Cape Seals as well, they're performing very well. So they do have some cracking, as you can see there, or maybe not, but it's there. Very fine cracks in the wheel paths especially. But the scrub Cape Seal has been a very good option. I like it a lot in the low traffic setting, and it seems to be doing very well here. Also, fiber mat has helped a lot as well. The thin overlays, again, same thing. Some of them with some rutting, and that seems to be especially for those cold recycle sections. Some of them have higher rutting at this point. And the same thing with IRI, but most of them are in the good condition category at this point. But they're still pretty young, less than 4 years old. This was the optimized design for our thin overlays. So most of them are what we call the asphalt binder replacement thin lay. So now instead of 50% wrap or 5% RAS, we have 11% wrap and 3% RAS. So a little more optimized, yeah. That equates to about 20% binder replacement, so it's not as aggressive as we were with the first ones, and they have performed very well. Again, there's some cracking in there. All of our treatments have had some type of cracking, or all of our treatment categories, I should say. For our recycle section, so like I said, we have cold in place, we had cold central plant with emulsion, with foam. We think of between 4 and 5 inches of recycling. And as expected, we got rid of a lot of distresses that were there, even though we didn't really have a lot to begin with. So now these sections are performing very well in terms of cracking, which is where we see a lot of changes over time for the other treatments, but not really here. And literally, this is the one crack that we have on our cold recycle sections. So I think that's good news. In terms of IRI, I find it interesting. Now we do see a little bit of change over time. But I don't see like a consistent trend of one section being the top performer and one the bottom performer, if you wanted to call them that. We do see maybe the thin lay on foam CIR is the one that's been more stable over time, and then the other ones tend to have an increase, very slight, but still an increase. If we look at rutting, it's kind of the opposite. So now the one that was pretty stable for IRI is probably the one that's changed the most in terms of rutting. But again, we're still in that good to fair range. We're not too concerned with that. We have some thin lays that are OGFCs, I guess, for the added benefit of redirecting water from the surface and not having so much spray and that sort of thing. They're all, again, performing very well, all in the good condition category. It's hard to see cracks on an OGFC pavement, so that's another thing, but they are there for some of the treatments. So one of them had a PG 67 minus 22, and that one has a crack in there. Again, this is like the only crack that's in there for those types of treatments. We do permeability in these sections, again, to assess basically the life of just the treatment. We've attempted to do permeability on the other treatments and couldn't really get a reading, so that means they're performing very well and keeping the water out, but we just don't have the data. To summarize, yeah, it depends. Performance depends on many factors: climate, traffic, initial conditions especially. For climate, some of the trends that we see in the south, we also see them in the north, so that's good that there's the similarities in there. They do have their own problems, of course. Most of the things that we've observed seem to be similar in both places. The treatments can expand pavement life. That's not a question. The question now is, how do we really quantify that? And what we have seen right now, most of the change happens with cracking, but we're looking at everything and making sure. We could have a sudden collapse that changes IRI dramatically, and then that means you have to do something. So we look at everything, and we look at other things like I said, friction, texture, and all of that, because if one of those fails and it requires you to do something, then that's the end of the life of the pavement. Our combinations seem to be very promising, so they have shown very good results so far, and we like those. Everything has outperformed the control section, so obviously we want to do something. But if we're going to go through the trouble of doing something, we want to do what's more cost-effective and use our money wisely. This phase 2 of the study, another 3 years of data collection, is going to be critical to start building these curves and determining and quantifying what the benefit is. Some of those treatments, I'm not sure that after 3 years we're going to see much change. With those where we saw basically still a flat line. So I don't know. I always say that's job security for me. If you want to see more information, we have our website. We have a section dedicated to test track. Within that, we have our pavement preservation experiment. You can find more information on the treatments, our background, any report or any other publication papers that we have. At least we'll have the reference in there, if not the document, so you can keep an eye on that, and we'll have more information. And with that, I don't know if you have any additional questions.
So we've seen all the data on the crack sealing prior to a single micro or a chip seal, but you guys don't crack seal prior to double micro or thin lays, correct?
Yes,
so
correct.
We do, and I guess, I mean, I'm just going on the assumption that it's going to be better by doing that. So, I mean, is there any data anywhere about to look at that to make sure that it's hard to believe that it wouldn't be better,
Yeah.
but science is always nice to have, you know?
Exactly.
So.
And that's some of those statements that, well, we knew all of this, but now we have the numbers to back it up. I don't have any specific sources for that information, but yeah, I would assume it's still even better if you combine it. How much better is the question?
We all see that shadow that comes where the crack sealant shows underneath that chip seal. Has there ever been any work done to determine if that truly is the crack sealant bleeding through, or if it's just that the emulsion bleeds because there's no absorption into the existing pavement?
We know where those cracks were, so we have the crack map before and after, and I guess we're going to the assumption that it is just the sealant because that's where the crack was, but it could be some emulsion as well. But if we just look at the location and where we see that shadow now.
Oh yeah, we all know it's there. We all
Yeah.
know it's there. I just was wondering what, if that truly is that polymer modified crack sealant coming through or
There
not.
could be a little bit of both, I
Yeah,
think.
that makes sense.
I noticed there's like maybe one or two treatments where the fair precondition was outperforming the good precondition. Was that just really tight and just shows in the graph, or I think the single chip I think was one of them, but
The fair condition is what?
the pre-condition or the pre-treatment fair condition was outperforming the pre-treatment good condition
yes.
just by hair, but
Yes,
but you said
yes.
it's 1,000 points, so
Yes, exactly.
scatter maybe gets
There's
out
a
at
lot
that point.
there's a lot of variability in the data. In sometimes when we did that division of taking what was like within one treatment, we have some areas that were good, bad, blah blah blah. Sometimes we only had maybe one subsection that was fair, for example. So that's probably not really representative. So we need to do further work to see where we combine some of the things. So maybe we don't have a good and a fair, we'll just have a good to fair curve. So that could be just the size of the sample.
So I have roughly two questions. Is one is you did crack seal with other combination, and is so my question is you crack seal first? Do you wait how long you wait for the other treatment? That's one question, or you just do right after you open the traffic?
In the real world, you will want to wait a good amount of time, but because this was research and had to be done pretty quickly, I think it was a matter of like a couple of days only. So
Couple days. Okay, thank you. And the second is, with your data is with crack seal, how much cracking you observed, and without you have control as well. So how long you wait for the observation? Is a year or a month? So
we are testing month to month. So right now we're showing kind of the summarized part of the graph, but we have monthly data. And then we decided that was a little too much, so now we're moving into more like the quarterly details. But we have a lot of data in between.
Two things. First of all, with the traffic data and performance data you have, do you plan to come up with some sort of traffic design factor for those treatments?
Not really. I looked at plotting instead of time using traffic, but I don't think that's very useful for the agencies. People are all usually thinking in terms of time and years and how much that treatment will buy them. And also when we, for example, for Lee Road, I've tried taking both lanes and just plotting everything in terms of easels, because I thought that would make more sense and that everything was going to line up, and that wasn't the case because pre-treatment condition was so important. So in the one that we had more traffic, we also had more damage to begin with, so things don't really align very well in terms of traffic.
So in terms of that recycled work where you showed some performance indicators and there were differences, maybe practically they're not different, but any thoughts why we see that difference among those recycled sections, foam versus emulsion?
Yeah, I don't have an answer right now. I don't see like a common factor, one being the worst performer in terms of all the different factors. It seems to be that it varies, so maybe it's just variability right there.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.